time when I was discussing with you the testing of the hypothesis, I had taken the null hypothesis and I tested it. And when the value was not significant. Now let us take another problem today and let us see if the values are significant, then how do we do it? Bahadur, we are not considering the nominal data and the ordinal scale data. I am only considering at present interval scale data and the ratio scale data. If you want nominal, I will do it, no problem at all. So let us have one more example and let us see. Mamta, you can have as many of hypotheses as you like. There is no rule. Only the rule is if you have one objective for which you have the quantitative data, then you must have minimum one hypothesis. But if you have one objective and you do not have quantitative data, then you cannot have hypothesis. Therefore, I have already told you that there might be researches where you may not have hypothesis at all. So hypothesis is zero. You do not have, you don't require. And when you require, you may have one, you may have two. So there is absolutely no rule. So this is Mamta. I hope now you are clear about it. So now I am taking another example. I am taking a title like this. A study of job satisfaction of teachers working in government senior secondary schools of Jabalpur. Suppose this is my title and here my variable is job satisfaction, and you will have the data which will be on interval scale, and my objective can be to compare mean scores of job satisfaction of arts and science teachers. Suppose this is my objective and my hypothesis is that there is no significant difference in mean scores of job satisfaction of arts and science teachers. And now let me have the scores. Can you tell me how many variables are here in this objective? Can you name the variables from the objective? Can you name the variables from objective? Mamta, you have not given the complete answer. Shalini, your answer is correct. So any other participant like to answer? No, Mamta. No. This is not the correct answer. Any other participant like to answer? From the objective, find out the variables and tell me which are the variables. No, Jyoti, that's not correct. No, Bahadur. Bahadur, your answer is not correct because I do not have a gender. From where the gender has come? Read the Bahadur objective. I have not written gender. And Mamta, you have written arts and science. These are two different things. So my dear friend, the correct answer is one variable here is a job satisfaction and another variable is a stream, arts and science. So these are the two variables and stream is a discontinuous variable and job satisfaction is a continuous variable. So let me have the SPSS and then let me try to enter the data. So I first of all go to the variable view and here, do you want me to write job satisfaction first or stream first? Which one do you want? Do you want the stream first or job satisfaction first? All right. Jyoti, that depends upon the tool which you will be using. For job satisfaction, there will be a job satisfaction scale. And the scale will have the data which will be on the continuous. Now, Divya, when you say medical waste, there are, you say medical waste management. You may have different ways of managing the medical waste. So it can be medical waste management strategy. That will be the variable. Or you can say medical waste management ways, strategies. That is a variable. Treatment is a variable. It's not recycling. The ways of recycling. The ways of recycling becomes a variable, not recycling only, because there are different ways to recycle anything. Then disposal options. This is a variable. So therefore, you should know which one is a variable and which one is not a variable. Jyoti, do not worry. I will be teaching you tools. And in that tools, I will explain everything. Nothing to worry about it. So let us go ahead. So I go to the variable view and let us say, if you want to write job satisfaction, so job dot satisfaction. And this is a continuous variable. I can click like this. Another is a stream. And stream is a discontinuous variable. And we have only two levels of the stream. One, let us say arts stream. Two, let us say science stream. So these are the two streams. I say okay. And now I go to my data view. Now here, if you want, you can enter the data of the job satisfaction first, and then the stream, or you can enter the stream and the job satisfaction, the way you want. Suppose my job satisfaction, the minimum is 5 score and maximum is say 40. So from 5 to 40. So let us enter the data. I'm entering the data of the job satisfaction first, or you want to say first job satisfaction and the stream. He belongs to the science stream. Say he belongs to the science stream. He also belongs to the science stream. Let us say another one. He belongs to the arts stream. He is from the arts stream. So you can do like this, or you can enter the data of any variable first, and then you can enter the data of the another variable, no problem. Suppose I have so many. Let us enter the data of the stream. I am entering just randomly, but you have to enter whatever is the stream. So I have entered the data. Now I go to analyze. I go to analyze. Now where should I go? Can any participant tell me from where should I go now? Now I should go to the compare means. In compare means where? Then I should go to independent sample t-test. So I go to independent sample t-test. My test variable is a job satisfaction, and grouping variable is a stream. The under grouping variable, you should always enter the discontinuous variable, not the continuous variable. So I have the two streams. It is 1 and 2. These are the codes I have written. Then I say okay, and now I say okay. So now this is the result of your analysis, which you have got. Now here see, this is the value of the t, and it is not significant because the value is, the error is 7.9% error. The error should have been the 5% or less than 5%. So do you want that I should make some changes so that I have a variable, I have the value which is a significant value. So should I make changes in the data which I have entered so that it becomes a significant? Because I have already explained which is not significant. I want to explain you if it is significant, then what should we do? So let me change some of the values. I'm changing the values. So I'm changing the values, let us say. Let's say I've changed two values and see what is. Now the value is almost significant. Let us change one more value. Now the value is significant. Here you can see it is significant. So now if the value is significant, then how do we go about? So let us make the table and see how do we write. You should note down the value. Arts stream, the mean is 21.89. I am also writing and you can also write so that we can use that. Arts is 21.89 mean. Standard deviation is 5.91 and N is 9. Science is 25.69. Standard deviation is 2.39 and N is 18. And the T value is, it is given minus, but it is not minus. Why minus has come? Because 21 minus 25. If I do like this, if I enter the one first, say this is 2 and this is 1, and you see the value. It is the same value of the T. Here it is 2.401. This is also 2.401. All values are the same. And the minus has come because it is the smaller value was written first, that 21.89 minus 25.69. But the T value cannot be negative. It's always positive because it is the difference. And difference is a scalar quantity. It is not a vector quantity. Since it is a scalar quantity, so the values have to be positive always. So when it is like this, you should enter the positive T value. So 2.40. And the significance is 0.05. And the DF is 25. So let me use it to test my hypothesis. So this is my objective. Now, what can be the caption heading? Can any one of you tell me the caption heading? Stream-wise comparison of mean scores of job satisfaction of teachers. This becomes my caption heading from this particular objective. Then I say the second objective was to compare mean scores of job satisfaction of arts and science college, science teachers. The data were analyzed with the help of t-test, and the results are given in table, say 4.2, because that was the 4.1 table I wrote on that day. So it is 4.2. Now I say table 4.2. Now here I insert the table. Now here is a stream. This will be mean. This is SD. This is N. This is T value. Now here I say arts, then science. The mean job satisfaction of arts is the 21.89, that is 25.69. SD is 5.91 and 2.39. N is 9 and this is 18. The T value is 2.40 and it is significant at 0.05 level. Now you see here, what is the degree of freedom? Here the degree of freedom must be equal to 9 plus 18 minus 2. How much will it be? It is 25. Is that all right? So let us see the T value. Now let us see the T value. DF is equal to 25. This is 25. And the value at 0.01 is what? This is 0.05 and this is 0.01. And my value is calculated value is 2.40. So tell me, is it significant at 0.05 level or 0.01 level? You can see here, this is 0.05, this is 0.01. At which level is it significant? You are right. So if you want to use this particular table, you can use. If you do not want to use, you need not to use it. Because in the SPSS output, automatically it has given you that this value is significant at 0.05 level. Is it clear to you people? And this is when I'm using the two-tailed test, because I have a null hypothesis. Okay, now we go ahead with the interpretation. So this value is significant. So if you want, you can put 1 star, and below you can put 1 star, and you can write significant at 0.05 level. If you do not want to write like this, then you should not write. And you should not put a star here. If another is, you write remark. And then you write the p-value is less than 0.05. And p must be small, because the small p represents probability. So that means the probability that the error is less than 5%. And here I will write stream-wise mean SDN and p-values of job satisfaction of teachers. So this should be the caption, the table heading. Can any one of you tell me what should be my first sentence here? What can be the first sentence? I'm waiting for your answer. No, Harsha. No. Here my first sentence will be from table 4.2. It can be seen that the t-value is 2.40, which is significant at 0.05 level with DF equal to 25. So this must be my first sentence. What can be the second sentence? Yes, Shalini, yours is correct. What can be the second sentence here that I should write? Now the second sentence is that it indicates that there is a significant difference in mean scores of job satisfaction of arts and science teachers. Because the T value is significant, so that is why job satisfaction, the mean scores of job satisfaction of arts and science teachers differ significantly. That's what I have written. Thus, the null hypothesis that there is no significant difference in mean source of job satisfaction of arts and science teachers is, what should I write? Is rejected or is not rejected? Shalini, excellent. You are very good, Shalini. Keep it. So, is rejected. So, this is called testing of the hypothesis. Now, the testing of the hypothesis is over, but the interpretation is incomplete. So I'm proceeding with the interpretation further. The mean score of job satisfaction of arts teachers is 21.89, which is significantly lower than science teacher, whose mean score of job satisfaction is 25.69. Now, it may be said that science teachers were found to have significantly higher job satisfaction as compared to arts teachers. Now this becomes my finding. So it is so simple that if you move systematically, then it is not very difficult to come out with the finding. So I have taken two examples. One, when your value was not significant, and another when your value was significant. Now I'm taking the directional hypothesis. The data remain the same, the calculations remain the same, the t-value will remain the same, only the change in the interpretation. Let us see what will be the change. So I'm copying and pasting, and then I'm trying to tell you how exactly it has to be done. Gaurav, we cannot write the word accept. That this value is not rejected. The accept word you can write when you collect the data from all members of the population. And in social science, your maximum allowed error is 5%. So therefore, if in the 5%, the value is significant, and therefore your null hypothesis is rejected. So your maximum allowed error in research is 5%, not more than 5%. Less you can have as many as you like, absolutely no problem. अभी मेरा वेबिनार चल रहा है नहीं भाई 7:30 से 9 बजे चल रहा है ये तो मैं कंप्लीट कर दूं फिर कर चलो ओके तो गौरव जी you cannot, you have to test your hypothesis either at 0.05 level or at 0.01 level. You can't test on the same value at both the level. It's not possible. I told you, if you remember, that if your value is significant at 0.05 level, then automatically it is understood that it is not significant at 0.01 level. So you cannot just write both. You have to write only one. And if your value is significant at 0.01 level, then it is understood that it has to be significant at 0.05 level. I hope you understood that on that particular day. Gaurav. So you only have to test it, whatever is the highest. Here highest is 0.05. So you cannot talk about 0.01. Okay. Now I'm just copying and will tell you if my hypothesis is a directional hypothesis, then how will I change? So my data is same, my value is same. This will be the same, stream-wise comparison of mean scores of job satisfaction of teachers. This will also be the same. The second objective was to compare the mean scores of job satisfaction of arts and science teachers. The data were analyzed with the help of t-test and the results are given in table 4.2. Exactly the same, no problem. The table heading will be the same. The first sentence that from table 4.2, it can be seen that the t-value is 2.40, which is significant at 0.05 level with df is equal to 25. It is the same. Now the second sentence is related with the first sentence, and this will be the same. It indicates that there is a significant difference in mean score of job satisfaction of arts and science teachers. Now the change will be in the third. In the third is, instead of null, I will write directional. Does the directional hypothesis that there is, I cannot write no. There is a significant difference in mean score of job satisfaction of arts and science teacher is, what should I write? Is rejected or is not rejected? What should I write here? So your directional hypothesis is rejected or is not rejected? Yes, Rawat, your answer is correct. Patnaik, your answer is correct. Rajak, your answer is correct. Shalini, Chauhan, your answer is correct. So I should write is not rejected. Is not rejected. This is the difference. Rest sentence will be exactly the same. So when you are writing your null hypothesis, null form of the hypothesis, or directional form of the hypothesis, this will be the difference. And even if you see the value in the one tail, this is the value which will be 0.05 level. This is the one tail test and this is 0.05. And two tail is, this is 0.01. So let me give you the my DF was 25. So this is the value which is given here under 0.05. And this is the value which is given here under 0.01. In the one tail test, this was two tail test. This was two tail test. Now tell me whether our value is significant at 0.05 level or 0.01 level here. My calculated value is 2.40. So is it significant at 0.05 or 0.01? Yes, Harsha, your answer is correct. Rawat answer is correct. Rajak answer is correct. Patnaik correct, Chauhan correct. So you have understood it. So therefore you have written it is significant at 0.05 level. You have already written. So if you have written the directional form of the hypothesis, provided you have the strong base. If you do not have a strong base, then forget about it. Then you cannot write the directional hypothesis. You have to formulate the null form. And that is why in majority of the researches, the hypothesis is formulated in the null form because they do not have a strong base. So is the testing of hypothesis clear or not? Have you understood when to use one tail test and when to use two tail test? So only the thing is this, that if you are having a hypothesis which is written in the directional form, then you have to see the values which are given under one tail test. And if you have the null form, then you have to see the values which are given for two tail test. It is so simple, and rest interpretation is very clear. Is it all right? So do I proceed further? Now, there is only one important point that I have to explain to you. Jyoti, it is a wrong title. It cannot be the title of the research, it is wrong. And there is no variable in this particular title. So title is technically wrong. I have told you, were you present, Jyoti, when I was telling you how to write the title? Jyoti, were you present? If you present, then you should find it out yourself. That in this one, this cannot be the title of a research. This may be the title of a paper or maybe the title of something else, but cannot be the title of a research. So it is wrong. Now let us go ahead to understand the type 1 error and type 2 error. Now please understand. Suppose my DF is equal to 26. This is 26. And this is the value under 0.05. And this is the value under 0.01. If my value is 1.87, then what have you to say? Is it significant or is it not significant? Is it significant or it is not significant? Yes. So please see, it is not significant. And let me write, the moment I say it is not significant, it is understood that it is not significant at 0.05 level. So let me write is not significant at 0.05 level. Then what is the meaning? Is your null hypothesis is rejected or is not rejected? Is null hypothesis rejected or not rejected? So therefore, the null hypothesis is not rejected. Now, if you see this value at a lower level, you see this value at a lower level. This is the lower level, because when you go on the left-hand side, the error increases. Now, if you have to see, then what will you say? Is it significant or is it not significant? It is significant at which level? It is significant at 0.10 level. Then what is the meaning? That it is not significant. That means that here I should have written means do not differ significantly. And therefore null hypothesis is not rejected. Because here it is significant, that means differ significantly. And it means differ significantly, what will happen to the null hypothesis? What will happen to the null hypothesis? So null hypothesis is rejected. Now understand, I'm speaking something very important and you should understand now. That in reality, the null hypothesis should not be rejected, but researcher decides to reject it. It is called type 1 error. I repeat, in reality, the null hypothesis should not be to reject it is called type 1 error. Is it slightly clear to you or not? So in reality, the null hypothesis should not be rejected, but the researcher decides to reject it is called type 1 error. Or is called alpha error. Is it clear? Have you understood this part or not? That means you have any value, whatever may be the small value of the t, it will be significant at some level. That means the researcher is accepting a higher error. So that is the problem. Now let us take another one. Suppose my DF is equal to 29. This is 29. And my T value is equal to 2.045 at 0.05 level and 2.76 it is at 0.01 level. Suppose here my calculated value is 2.045. Then what should I say? Is it significant or is it not significant? What should I say? Is it significant or is it not significant? Okay, so that means it is significant. At 0.05 level. What the meaning? The meaning is means differ significantly. And it means differ significantly, then my null hypothesis is rejected. Now, if you see the same value at 0.01 level, if you have to see this value at 0.01, what is your conclusion? What do you think? Is it significant at 0.01 or not? So that means it is not significant. Let me write at 0.01 level. So if the value is significant at a lower level, then it may not be significant at a higher level. But if the value is significant at a higher level, then it has to be significant at a lower level. This is important. So it is not significant. What is the meaning? Means do not differ significantly. And it means do not differ significantly. What is the meaning? That null hypothesis is not rejected. Now listen carefully. In reality, the null hypothesis should be rejected, but the researcher decides not to reject it is called type 2 error. I repeat, in reality, the null hypothesis should be rejected, but researcher decides not to reject it is called type 2 error. So in reality, the null hypothesis should be rejected, but the researcher decides not to reject it is called type 2 error or beta error. and the alpha error and beta error must be equal to 1. Alpha error plus beta error is always equal to 1. So this is what you should try to understand. Now, if you want, I can give you a very simple way to remember. Do you want or not? If you want, I give, otherwise I proceed further. Okay, let me give you. And the one which I am giving you, this you can find out in the book Process of Research. Process of Research in Education by David J. Fox. This is the book. What now I am giving you the table, it is given in that. And here what you have to do is, you have to make a table. I insert the table. Now here I say, researcher's decision. The researcher decision can be that null hypothesis is rejected, and another can be that null hypothesis is not rejected. And the true situation can be that null hypothesis is rejected, or another can be null hypothesis is not rejected. And this is the true situation. This is the true situation. And true situation can be your null hypothesis is rejected, and another can be your hypothesis is not rejected. Now, if the true situation is that your null hypothesis is rejected and the researcher is also rejecting it, then any error? Is there any error or no? There is no error. So therefore, there is no error. Now here it says the true situation is that null hypothesis is not rejected and you are rejecting it. So is it type 1 error or type 2 error? Is it type 1 or type 2? Yes, थोड़ी आवाज कम करो. अरे आवाज कम कर यार. आवाज कम. हाँ जी. It is type 1. So this is the type 1 error. Now here The true situation is that null hypothesis is rejected and the researcher decision is null hypothesis is not rejected. Then which type it is? If you have understood the type 1, then this becomes automatically type 2. And here there is no error. So this is the table. If you want, you can remember, it will help you. And if you do not want, the choice is yours. Now, with this, I have completed the testing of the hypothesis and all. Any question you want to ask before I go to the next step? Any question you want to ask, please ask me the question, then I go to the next topic. I'm still waiting for your answer, for your question, not answer, I'm sorry, for your question, so you can ask the question. No, no, Gaurav, it cannot be the same. That is why they are given two different names. It cannot be the same. Either it is type 1 error or it is type 2 error. You cannot have both. It's not possible. So under the steps of research, I have given you the first one, identification of problem. And under identification of problem, I have talked about variables. I have talked about sources of problem. Then I have talked about title, that how exactly title has to be written. And then I have talked about the objectives, that how objectives have to be written. Then next step is the formulation of hypothesis. I've already explained you that what should be the nature of the data so that you can formulate hypothesis, and what should be the nature of the data when you cannot formulate. Now, Gaurav, tell me, as far as maintaining of the type 1 error and type 2 error is concerned, what is the meaning of maintaining? What do you mean by the word maintaining? Because whenever you do research, either you are having type 1 error or you are having type 2 error. If your results, if your calculation, if your data are not all right, if you are manipulating the data, then the answer is there is a problem. Maintenance does not mean kam karna. If you have to do, you want to, then you should test your hypothesis by taking 0.05 as a level of significance, but not at 0.01. This is, so if you are taking 0.05 as a level, perfectly correct. Now, Patnaik, think about it. That if your type 1 error is 80%, what can be your type 2 error? It has to be 20%. So 80% means 0.8 and 20% means 0.2. Total is 1. That when you say that there are 80% chances that your level of significance, that your hypothesis is not rejected, that means there are 20% chances that your hypothesis may be rejected. And therefore the total becomes 1. This is how it comes to 1. Now, the third step is the data collection. And I have already told you, under data collection, the first important thing that you should understand is about the sample. And in this sample, you should understand first the universe. What is universe? Universe refers to whatever exists on this planet. Whatever exists on this planet is universe, part of the universe. Ocean is the part of the universe. Plant is the part of the universe. Animals are the part of the universe. Human beings are the part of the universe. The schools, the colleges, the book, everything the part of the universe. Then another is called population. Population refers to well-defined portion of the universe. If you want to do research on plants, then you are taking only a well-defined small portion of the universe. Because you are not taking animals, you are not taking human beings, you are not taking ocean, you are not taking mountains, you are only a particular one. If you want to do research on class 10th students of government school, so this is your well-defined portion of the universe. That means it is class 10th students of government schools of Jaipur. So you are not considering the class 10th students studying in government school in Ajmer. No, it's only Jaipur. So that is why population is a well-defined small portion of the universe. And then you have another one, sample. All of you know the general meaning of the word sample. You do use in your daily life. Okay, please take this sample and show it to your family members. So what is sample? Sample refers to small representative portion. The small representative portion of the population. Now, when you bring a sample of the rice, when you bring a sample of the wheat, when you bring the sample of some other thing, so that sample represents the population. Now, your population does not represent your universe, because the universe is heterogeneous and your population is homogeneous. If your population is not homogeneous, then the representation will be difficult. So this is the definition of universe, the population, and the sample. Now another definition is frame. Now what is the meaning of a frame? The room in which you are sitting, there are 4 walls. So the 4 walls of your room is the frame of that particular room. Because the portion on the inner side of the wall belongs to that particular room, and the portion outside the wall doesn't belong to this particular room. That is the frame. Now, you know, in science, you have labs. And in labs, you have got the stock register. In the stock register, you have the list of all the items which are available in the lab. So that becomes your frame. Now, if you go to the market and before going to the market, you make a list of the items which you want to purchase, then that list becomes your frame. If you go to the hotel, you take your lunch or dinner, then the menu card which will be given by the hotel person, that menu will contain the name of the vegetable, of soups, of bread, of and other things which they are supplying. Anything which they do not supply will not be the part of the menu card. So whenever there are elections and you go to cast the vote, so you have to see whether your name is in the list which is available on that particular booth. If your name is not in that list, then rest assured you are not allowed to cast your vote. So the frame means listing. Frame refers to listing all members of the population. So this is how we define frame. So I have defined universe, and in many of the books, they are using universe and population word interchangeably, which is technically wrong. Because universe and populations are not same. You understand that. So another word is sampling. Sampling refers to the procedure used for selecting sample from the population. This is the definition of the sampling. So sampling refers to the procedure. It is a procedure of selecting sample from the population. And therefore, there are different sampling techniques. You can say there are sampling techniques or there are sampling methods. And these sampling methods have been broadly classified in how many categories or how many classes? Do you have any idea that sampling techniques are classified into how many? Can you name that? Name. Yes, you are right. They are, one is the probability sampling, and another is called non-probability sampling technique. So all sampling techniques have been classified in these two classes or these two groups or these two categories. Now, your probability sampling techniques, you know the names, or should I tell you the names? Do you know the names or should I tell you? The names are, one is called random sampling technique. Another is called systematic sampling technique. And another is called stratified random sampling technique. And another called stratified proportionate random sampling technique, and another is called the cluster sampling technique. And the another one is called multi-stage sampling technique. Multi-stage sampling technique. So these are the different sampling techniques which belong to the probability sampling technique. And the non-probability sampling techniques are, one is called purposive sampling technique. Another is called judgment sampling technique. Another is called incidental sampling technique. Another is called quota sampling technique. And the last one is called snowball sampling technique. Now, dear friends, you have to understand why such a classification. Why the snowball sampling technique cannot come under the probability sampling technique, and why cluster sampling technique cannot come under non-probability sampling technique. Do you have any answer? Do you know why such a classification? You can use them interchangeably. Yes, some people write technique, some people write method, it doesn't make a difference. Rawat, what is the meaning of it? Rawat, what is the meaning of your answer? If the frame is available, what will happen? Now, let me explain to you, and then I will close. No, no Patnaik. Let us see what is the meaning of probability. If I say the probability of selecting Patnaik is equal to the number of Patnaiks divided by the total number of participants. If I know there is only one Patnaik and there are 27 participants, so I can find out the probability of selecting Patnaik out of 27. But suppose if the total participant is not known, if the total number of participants is unknown, then can you calculate the probability of selecting Patnaik? If the total number of participants is unknown, is it possible to select? Is it possible to calculate the probability? The answer is no. Then what is the meaning? The meaning is that when I say the probability sampling techniques means that you know the total or you know the size of the population. So that means size of the population is known. What is the meaning? The size of the population is known means the frame is available. If the frame is not available, then you do not know your total population. So if the frame is available, then you must use the probability sampling technique. And if the size of the population is unknown, the probability sampling technique, size of population is unknown. Therefore, frame is not available. If I ask you that whatever the city to which you belong, Do you think, do you know the total number of pickpocketers? Do you know the total number of drug addicts? Do you know the total number of broken families? So there are many situations in which you do not know the total number of the broken families, total number of this and total number of this. And if you do not know the total number, then you cannot calculate the probability. And therefore, it cannot be the probability sampling. It has to be the non-probability sampling technique. If you want to work on drug addicts, do you have the people list who are drug addicts? The answer is no. So therefore, there are situations. Do you know how many street children are there? So you don't know the street children, the total number. And if you do not know the total number, then you cannot use the probability sampling. You have to use the non-probability sampling technique. So in social sciences, there are instances, there are situations where the non-probability sampling technique will be the most appropriate sampling technique rather than the probability sampling technique. So more we will talk about tomorrow. So you will decide and tell me whether I should explain you the non-probability sampling technique first or probability sampling technique first. That you can decide tomorrow and tell me, I will tell you. Any question you want to ask before I say bye-bye to you? Any question? If no question, thank you very much. Keep learning. Stay safe.